Ever scrolled through those AI image generators? You know, the ones where you can type in something like a cat wearing a monocle riding a unicycle and it just like creates
A
it.
classic, always a good choice.
Right. But like behind the scenes, it's more than just quirky art. That's powered by something called vision language models, VLMs for short. Basically, these things are learning to actually see and understand images in a way that's, well, kind of mind-blowing, even to the point of answering questions about them.
And what's really fascinating right now is that we're seeing this surge in incredibly powerful VLMs. I
Yeah.
mean, you've got GPT-4V, Claude, the list
Mhm.
goes on. But there's a bit of a catch. A lot of them are proprietary, kind of like walled gardens.
Yeah.
We get to see the amazing things they can do, but the actual inner workings, the how it all happens, that's still a bit of a mystery.
It's like knowing a magic trick is cool, but knowing how it's done, that's way more interesting.
Precisely. And that's why this deep dive into Molmo is so exciting, because it's a family of VLMs that's deliberately designed to be open source, right?
Mhm.
But here's the thing. It's not just open for the sake of being open. We're talking high-performing, rivaling, even surpassing some of those closed-off models we were just talking about.
Okay, so we've got open source, high performing. That's already two big check marks. What's the secret sauce here? What makes Malmo tick?
Well, a lot of it comes down to how it's trained. The researchers behind Molmo actually created something called PixMo, which is basically a collection of data sets that's specifically designed to teach these VLMs. And they did this with the Allen Institute for AI and the University of Washington, so you know it's top-notch stuff.
Okay, so let's break this down a bit. We've
Okay.
got Momo, the VLM itself, and then we got PixMo, this like special training regimen. Where do we even start with something like this?
A good place to start is understanding how Molmo learns to even describe images in the first place. Think of it this way. If you were teaching a child about the world, you would just like point at a tree and be like, tree, right? You'd have a conversation with them, ask questions, get them to really engage with what they're seeing.
So it's about more than just showing the AI, what, a million pictures and slapping a basic label on them.
Exactly. And that's where one of the core data sets in PixMo comes in. This one's called PixMo Cap. See, instead of relying on short written captions, they had human annotators actually describe the images out loud. And not just for a few seconds, we're talking a full 60 to 90 seconds of description per image.
Wait, hold on. They had people like talking to the AI. That's a pretty wild concept.
It might sound a bit unusual, but think about how we naturally describe things when we talk. We go into way more detail. We talk about the relationships between objects, their positions, those little nuances that you might miss in a quick written caption.
So it's about capturing that richness.
Exactly. That richness and complexity of the visual information. It's crucial if we really want AI to understand the world the way we do.
Makes sense. But they didn't just like hit record and feed that raw audio straight to Molmo, did they?
Oh, no, no, no. They took a very meticulous approach to make sure the quality of that data was top-notch. First, they had all the audio descriptions transcribed, right? Then they actually used a language model to smooth out any inconsistencies or, those little quirks we have when we speak, like all the ums and ahs and stuff.
So even though it's spoken language, they still wanted it to be super clear and consistent for training.
Precisely.
Yep.
And to top it all off, they even used a language model to condense those three transcribed descriptions. So they took those three and they crunched them down into a single, super detailed summary caption. So Momo's basically getting the best of both worlds here. The richness and detail of spoken language, but with the conciseness of a well-written summary.
That's so cool. They've managed to like capture so much more nuance than your typical image caption. But okay, I'm curious, how do you go from like understanding an image to actually acting on it? I mean, it's one thing to say, okay, there are 3 cats in this photo, but can Molmo actually do anything with that information?
That's where Momo's second stage of training comes in. It's called supervised fine-tuning. And this is where those diverse PixMo datasets we were talking about really come into play.
All right, so hit me with the highlights. What kind of training are we talking about here?
So one of the datasets that really stands out is called PixMo Ask Model Anything. And it's all about teaching Molmo to handle the kind of open-ended questions that, a real person might ask in a real-world situation, not just like simple textbook examples.
So instead of just asking what color is the car, it could answer something like, could you take that car on a road trip?
You got it. And to achieve this, they had annotators actually working alongside a language model. Picture this. An annotator picks an image, right? And they come up with a question about it. Then they feed that image's detailed caption. Remember those super detailed captions we talked about? They feed that to a language model. Oh, and they also include any text the AI could, like read directly from the image itself, like
Hmm.
using optical character recognition, OCR, signs, labels, that kind of thing. So they feed all that to the language model along with the question, and the language model takes a shot at answering it.
So the language model is kind of like a student trying to answer the question based on all the info it's given.
Exactly. And then the annotator acts as a teacher, providing feedback, guiding the language model towards a better, more accurate answer. It's a really clever way to generate these high-quality, diverse questions and answers that are actually grounded in the image's context.
It's like they're prepping Molmo for a real-world Q&A session. This is seriously impressive stuff, but I'm still kind of stuck on how Molmo can move beyond just understanding to actually doing something with what it sees.
Okay, so this is where it gets really interesting. They have another data set called PixMo points. And the basic idea is imagine someone literally pointing at a specific part of an image. Like, I'm talking about this cat right here.
Ah, I see where you're going with this.
Right, so this data set, PixMo points, it uses that concept, what we call 2D pointing. And they use it to teach Molmo to interact with this visual environment with this whole other level of precision.
So instead of just recognizing, okay, there are 3 cats, Molmo could actually pinpoint each individual cat.
Yes, and it goes beyond just locating and counting objects. With this whole pointing ability, Momo can start to explain elements within an image. For example, it could tell you the cat wearing the hat is sitting on the couch.
Wow, that's incredible. It's like teaching the AI to actually interact with what it sees. This opens up so many possibilities. But I'm curious, is this the only way Molmo learns to do things based on images? It's like they're teaching Molmo a whole new language, but instead of words, it's all about understanding and interacting with the visual world.
Exactly. And the cool thing is, PixMo points. It's just one example, right?
Yeah.
The researchers also included data sets for understanding documents that have, both text and figures, like being able to find a specific chart in a scientific paper. And get this, they even have one for telling time from analog clocks.
Which, now that you mention it, can't be easy for AI.
No, it's
Yeah.
surprisingly tricky. So they really covered their bases with these data sets. It's like they were anticipating all the different ways we might actually need an AI to see and interpret information in the real world.
Totally. So they've trained it, they've got all these different ways of teaching it, but how does it actually measure up? Did they put it to the test?
They did. They actually ran Malmo through a whole battery of tests. And not just those, like standard academic benchmarks, but this is the really interesting part. They also did a large-scale human evaluation.
Okay, so let's start with the brainy stuff. How did Molmo do on those benchmarks?
In a word, admirably.
Mhm.
They tested it on 11 common benchmarks. Things like visual question answering, document understanding, even those tricky object counting tasks we were talking about earlier. And what's remarkable is that Momo consistently performed as well as and often even surpassed other open weight models.
Really?
Yeah, and it even came close to the performance of some of those big proprietary models, the ones that are kind of shrouded in secrecy.
That's super impressive, especially considering that at its core, Molmo is built on this foundation of openness. But those benchmarks, they only tell part of the story, don't they? I mean, how do we know if Molmo is actually useful in, more realistic, everyday kind of setting?
That's where the human evaluation comes in. So to get a sense of its real-world usability, they had this big group of people compare responses from Molmo and other VLMs, kind of side by side. And they just asked people, which response do you prefer? Essentially, they were judging, which AI was the most helpful, the most engaging,
Yeah.
in a way that felt natural and intuitive.
So it's not just about getting the right answer. It's also about how that answer is presented, how useful, how relevant it feels to a real person.
Exactly. And I'm sure you won't be surprised to hear that Molmo consistently ranked among the top contenders, which really goes to show that it can generate responses that people actually find valuable and engaging. Not just answers that, tick the boxes on a technical checklist, but something that feels more human, more useful.
This is seriously exciting stuff. We're talking open, high-performing, user-friendly. It feels like a win-win-win for the future of AI.
It really does. And the best part is, the creators of Molmo, they're committed to keeping it open. They're releasing all the model weights, the PixMo training data, even the code they used.
That's huge. I mean, talk about opening doors. That opens up a world of possibilities for other researchers, developers who can actually go in. They can dissect. They can understand a state-of-the-art VLM. They can build upon its successes, maybe even find ways to, address its limitations. It's like this giant leap forward for collaborative AI development.
Absolutely. And I think that's what makes this whole deep dive so compelling, right?
Hmm.
Because Molmo isn't just another, incremental advancement in AI. It's really a testament to the power of openness and collaboration in this field. And by making these resources freely available, they're essentially empowering a whole new generation of researchers and developers to push the boundaries of what's possible with AI, leading to innovations we can only begin to imagine.
It's a good reminder that some of the most groundbreaking discoveries often happen when we share knowledge, when you have all these different minds coming together to explore new frontiers. And who knows what amazing applications and possibilities will emerge from this kind of like the spirit of openness in the world of AI. It's definitely something to think about as we continue to, dive deeper into this fascinating, always evolving field.